Okay, hope you're having a great day today. What we're going to do right now is we're going to check into our logarithms, and we're going to actually do the work that we've done in sections 3 and 4, doing all the conversions, doing all the rules for logarithms, and put them to use. We're going to be solving exponential equations, in other words, in exponential form. Sometimes we'll use logarithms, and to solve logarithmic equations, we'll put that into exponential form typically. So here we go. Let's go ahead and get started with this. Okay, so if we solve this, we know how to put this in our calculator. I'll show you that one more time just quickly here. But algebraically, what we have now is, because the x is in the exponent, what I'm going to do is do the magic step to start, which is basically say you have to recognize if I take the log of both sides, that's justified algebraically, because, anytime you do the same thing to both sides of an equation, that's okay. But what this allows us to do is bring the exponent out in the form of the power rule. Okay, we know the power rule now, so we can say, okay, I can rewrite this as 2x in front, log base 10 of 5 equals log base 10 of 16. Now our algebra isn't so bad, right? This is multiplication, so I'm going to go ahead. I'm actually going to do this in 2 steps. 2x equals log base 5, or log base 16 over log base 5. Put that in our calculator, and we get 2x equals 1.7227. Log base 10 of 16 divided by log base 10 of 5. Okay, divide by 2, and x is approximately was it 0.8613. Okay, so that's our new skill, basically, is solving algebraically. If I have an exponential equation, typically what we're going to do is go ahead and use logarithms on both sides. Okay, in our calculator, just a quick to review this guy. Done this before. On the y equals line, we're going to put 5 to the 2x. And on the second line, we'll put 16. And in my window, since I did the algebra, I know that x max of 5 is fine. Y max of 25 should be good. And graph, there's your exponential, there's your y equals 16, and then you can find that intersection. Okay? All right, let's do this one more time together here. Let's go ahead and look at this guy. 3x, 3 to the x equals 4. Okay, 3 to the first is 1. 3 squared is 9. I know my answer should be between 1 and 2. And we can just go log of both sides. And this is just x equals log of 3, log of 4. And x equals log base 10 of 4 over log base 10 of 3. And that turns out to be 1.26. Okay? Just one more quick peek at that, and that's the process. Okay? So solving these problems where we've had x in the exponent, this is our process. Now, this is what we just did, is basically like a form of the change of base formula. I was asked earlier this week, well, Mr. Roderick, what if you have an evaluate, so log base 6 of 12, and there's no good relationship between 6 and 12. In other words, I can't express 12 as a power of 6 readily and easily. Well, what we're going to do is rewrite this in what we call the change of base formula. So it's going to be log of the base number, the 12, over the log of the base. Okay, right? 6 to the what is 12. 6 to the 1 is 6. 6 squared is 36. Let's go ahead and check in our calculator and make sure we do this right. So I go log 12, close it up, divided by log 6. Okay, 1.38. That seems to make sense. Okay, round it to the hundredths. So evaluate. If I say if that equals x, then x equals 1.39. Okay, I'll let you quickly do this next one on your own. 4 squared is 16. 4 to the third is 64. So my number should be between um, 3 and 4. Actually, I'll go ahead and run that in the calculator. So we go log 82 divided by log 4. Yay, 3.178. Okay, got it. All right, let's keep moving. We can, oops. All right, so now those are exponential equations, okay? Those are basically exponential equations. We just did a logarithm change of base. Now we're going to basically see where x is in a spot in a logarithm equation, okay? So again, what are we going to do? If it's got an x in there, we're going to move that back into an exponential. What's the easiest way to do that? I put my 10 in there. Okay, I put my 10 in there. So I got log, oops, excuse me. So I'm going to go 10 to the what? 10 to the fourth, and set that equal to 2x minus 2. 10 to the fourth equals 2x minus 2. So that's the reason we kept working on those nice easy turning a logarithm into an exponential, because you need to recognize it in this setting. And again, there's variables in there, so you can't just rely on your calculator. Okay, so now we've got 2x minus 2 equals 10 to the fourth. So 2x equals 10 to the fourth, which is 10,000 minus or plus 2, and uh, divide that out, and you get uh, x equals 5001. All right, not too difficult, but knowing what to do in the original setting, this is the key, right? Knowing that, okay, that base of 10 is there, and knowing that I want to turn that into an exponential. But the math is actually pretty easy for you. Let's try one more of those. Again, just plug in a 10 there, and I go 7 minus 2x equals 10 to the minus 1. All right, now this is a good quick little algebra check. There's, that's 1/10. Okay, 10 to the negative 1. 7 minus 2x. Couple ways of doing this. Might be easiest probably is just instead of cross multiply, that's possible, but minus 2x equals 1/10 minus 7, so negative 6.9, right? And then so divide by 2, and x equals 3.45. Okay? And then one more of these for you. Oh gosh, 2 log statements with a variable in it. Okay, and again, as long as you know your rules in section 4, this is easy, because the first thing I'm going to see is, oh, that 3 is an exponent for the x, and okay, so I'm going to rewrite this, x to the third. And you're going to say, too easy, Mr. Roderick, because I know subtraction talks with division, so I can make one log statement. And from there, we're back where we started in this last problem. Put my little 10 in there, and I say, okay, x to the third over 2 equals 10 to the fifth. Okay, x to the third equals 2 times 10 to the fifth. Let's just write it like that. 200,000, right? Okay, and then For our intents and purposes right here, quickest, easiest thing to do is take the cube root there, and we get x equals 58.48. Bada bing. Okay? You'll be working with that in today's lesson. And again, to review the problem, there was a x in the log statement. There were multiple log statements. So first thing I did was crunch it into one log statement. So use that skill, and then I made it into an exponential. So use that skill, and then go ahead and solve for x. Okay, this is kind of a little capstone here. This, if you know what you're doing on this one, you are good to go. All right. Let's try one just for practice to make sure life is good as you head off here. So no exponents out in front, so subtraction talks to division, so I'm going to go ahead and write right away log base 10 6 over 3x, okay, and negative 2, okay, and now I'm going to say 6 over 3x equals 10 to the negative 2, which at this point, hopefully we can go 6 over 3x equals 1 over 100. So this one, it worked out to our benefit to write this as a fraction, because now this is a quick, easy cross multiply. 3x equals 600, x equals 200. Alrighty, that is it, folks. You can solve exponential equations by putting them into log statements, taking the log of both sides, and you can solve, you can use change of base, and you can solve with x in a logarithmic statement, either by changing it into an exponential right away, or having multiple log statements and crunching them into one log statement and then putting it into an exponential. All right, we will talk to you soon. Enjoy your day and have a great day.